Welcome to EBS Service Architectural Capabilities. In this section, we look at EBS performance. We look at how to improve the performance of our EBS volumes, how to scale our EBS volumes, how we can design applications so that it's highly available using EBS volumes. We'll look at the security tools that are provided by Amazon for EBS volumes. We look at the monitoring aspects or the monitoring metrics that Amazon provides when we want to monitor our volumes. We look at the pricing model, how much it costs to provision these EBS volumes for our instances. And then finally, we look at the interfaces or how we can interact with EBS service. We'll start with the performance aspects of EBS volumes. When you purchase provisioned IOPS, Amazon guarantees low latency, consistent performance for your applications. The one thing that we want to remember is Amazon measures the performance using 256 kilobyte blocks. So that means if you're doing 512 kilobyte read and write operations, that's considered 2 IOPS in Amazon's term. Another improvement we could make for our application is to use something called an EBS optimized EC2 instances. When you use EBS optimized EC2 instances, Amazon guarantees you additional dedicated capacity for your EBS input-output. This minimizes the contention between EBS I/O and the other network traffic that may be originating or that may be directed at your traffic. Next, we want to talk about the average queue length of your EBS volumes. This is a metric that is provided by CloudWatch, and it measures the number of pending I/O requests waiting on your device. So the higher the queue length on your EBS volumes, there are more processes that are waiting to read or write from your disk. So if you're running into higher queue length, you may want to increase the provisioned IOPS, or you may use the other options such as using RAID configuration on your EBS volumes to improve the read and write performance. There are two types of RAID configuration we can use: RAID 0 or striping, or RAID 1, the mirroring option. RAID 5 is not recommended for EBS volumes because the extra parity calculation that RAID 5 requires uses up the IOPS, and you may actually see degradation of performance. So the only recommended RAID configuration with EBS volumes are either RAID 0 or RAID 1. The other option you have is to use something called a 10 gigabyte network EC2 instances. You can also choose instances that have the 10 gigabit network connectivity so that your EBS performance is also improved. Now let's talk about the scalability options with EBS volumes. Like we discussed in the previous section, the largest volume you can create in EBS is 16 terabytes. And you can get up to 20 to 25,000, and you can get up to 25,000 IOPS with the EBS volumes. The other option, like we discussed earlier, is you can string multiple EBS volumes for scalability, using that is the RAID configuration we talked about, either RAID 0 or RAID 1. Now let's say you start a EBS volume with 10 gigabyte storage and it's getting full, it's 100% used or 90% used, and you need to increase the size of that EBS volume. The best option for you is to take a snapshot of that volume, create a bigger volume using that snapshot. And now the snapshot that you have is of the larger size, and your host can continue to use that larger size. The next concept we want to talk about is the availability of our EBS volumes. Like we discussed in the previous section, the data that we copy onto EBS volumes is automatically replicated in the same availability zone. If you want to have better performance and better availability, you could use them in the RAID configuration to improve the availability of our EBS volumes. Another important concept that we need to remember about EBS is they persist independently of the EC2 instances. So if something happens to your EC2 instance, it crashes or it goes away, your EBS volumes can still be retained. Your data is still, the data that you copied onto EBS volume still persists. So you can start a new instance, you can attach that EBS volume to the new instance, and you can restart your applications. The final feature we want to talk about in terms of availability is the snapshot copy feature. So if you want to copy the data from one region to another, you can take a snapshot and use this feature called snapshot copy to copy the data to another region. So this is typically done for either for disaster recovery, or if you want to move the data from one region to another, this is one of the easiest option to do that. Next, let's talk about the security aspects or security features that are provided by AWS. The first feature we want to talk about is the EBS encryption. So if you want to encrypt the data at rest, so this is the feature that you can enable. So any I/O, any input-output operation between the EC2 instance and the EBS is encrypted. And so are the snapshots that you take for those EBS volumes. Now you have two options when it comes to keys. You can let Amazon manage the keys, so they will generate the keys, they will use that keys to write data onto the EBS volumes, and they rotate the keys on a regular basis. Or if you want to choose your own keys, you can use a service by Amazon called KMS or Key Management Service to specify your own keys. The next option related to security is the snapshots. If you do enable EBS encryption, any snapshot that you take are also encrypted like we talked about. And in addition, the snapshots are private by default. If you want other accounts to access it, you have to give them explicit permission before they can access. If you have some data that is non-sensitive, or if you think that data is useful, it's going to be useful for other people, you can even make that snapshot public. Take this snapshot, create their own EBS volumes in their account, but that data comes from the snapshot that you made public. When Amazon creates a EBS volume and presents it to you, they wipe it clean using industry best practices. But if you want to, before you detach the volume, if you want to clean it, you have an option of doing that as well. Now let's talk about the monitoring aspects of EBS volumes. CloudWatch is a service that we use to monitor the performance of EBS volumes. CloudWatch provides metrics like read and write throughput, that is the number of operations per second our EBS volumes are doing. We can also look at the average queue length, the number of IOPS that are waiting on our EBS volumes. We can look at the average read and write size the volume is getting. We can also look at the latency our applications are experiencing for these EBS volumes. You can configure the alarm for CloudWatch. You can get an alert when any of these metrics go out of the range that you are expecting. In addition to these metrics, you can use traditional tools for disk monitoring like IOStat, IOTop, DiskStats for Linux systems. And if you are on Windows systems, there are tools such as Process Explorer, HDD Scan, and Crystal Disk Info. Let's talk about the pricing model for EBS volumes. So because there are three different types of EBS volumes, there are different pricing for those options. For general purpose SSD, you'll pay 10 cents per gigabyte per month. For provisioned IOPS SSD, the cost is 12.5 cents per month. In addition to that, you'll be paying around 6.5 cents for the provisioned IOPS per month. The EBS magnetic volume are the cheapest one. There you pay about 5 cents a gigabyte per month, but in addition to the storage, you're going to pay about 5 cents per 1 million IO requests. And the snapshots are about 9.5 cents, but it's based on the actual capacity used. So what does it mean? So let's say you provision an EBS volume of 100 GB, but your application is only using 20 GB out of it. So you're only using 20% of the disk. Amazon is still going to charge you for this entire 100 gigabytes. So even though you're only using 20 gigabytes, Amazon is going to charge you for the entire 100 gigabytes. Now let's talk about the interfaces or interactions with this EBS volumes. How do we create an EBS volume? How do we provision it to our EC2 instances? So like most AWS services, you can use the AWS console, you can use the REST API, or use the command line tool to create an volume and to provision or to attach it to the instance, and then when you're done, to delete from that instance. The one thing we want to remember is the EBS volume can be attached only to a single EC2 instance at a time. So this is like a USB disk. Only one instance can have access to that EBS volume. Multiple EBS volumes can be attached to a single instance. So that is the main primary distinction we want to remember. So how do you create an EBS volume? The first thing you need to do is find out the availability zone or AZ of the instance that you're trying to give the storage to. Once you determine that, you create an EBS volume in the same AZ. This is very critical. And once you do that, you attach the EBS volume to the instance. On the instance itself, you scan for new devices, you format or partition the volumes that are presented to the instance, you create the desired file systems. On Linux systems, you primarily create ext4 or ext3 file systems. On Windows, we create NTFS file systems. And then when the file system is created, you mount the file system and then you start using it. So this is the gist of creating an EBS volume, attaching it to the instance, formatting it, creating the file system, mounting it, and start using it. So in summary, we talked about the performance aspects of EBS volumes. We talked how to scale the EBS volumes using snapshots or using RAID configuration. We talked about the availability options for EBS volumes. We talked about the security aspects, the EBS encryption, and the secure snapshot feature. We talked about the important metrics we need to keep track for our EBS volumes. Then we talked about the cost model or the pricing for the EBS volumes. And then we looked at the high-level overview of how to create an EBS volume and present it to our EC2 instance.